and unlike the past times when it's went wrong, it will not happen. So, okay, let's start. First of all, let me make few things very clear to you that I'm not going to provide the detailed solution because one is that due to the shortage of time, and second thing is that due to the like there is no point in providing detailed solution so people can mark it up readily and vomit during exam. But I'll surely provide you clues, hints, so that you can make, if you are willing to understand, you can understand it and you can uh, solve the problem. First thing first, let us consider this problem and let us try to understand what is happening here. How can we address this problem? Here, please try to understand. Let me here we will be using kind of superposition theorem. So superposition theorem. Let me draw the two circuit diagram together so you can understand this. I request you to read the problem by yourself. That will save our time. Otherwise, if I keep on reading this long statement, this will unnecessarily waste our time. I'm just drawing a rough sketch, uh, but during exam, students are expected to draw a neat sketch using pencil and because at the end of the day, engineering is all about presentation also, especially when you are expecting something in return. In this problem, the dot position becomes very important to us. So this is my primary site. This is secondary site. Feeding a resistive load. Since it is a resistive load, there is no need to maintain the phase sequence as well. We are assuming balanced resistive load, so you can connect it in any way. It is not going to give any difference in that manner. So this is my circuit for first. And here the current drawn by this is I. The governing equation should be in this case. Actually, here if we consider that the mid tapping, whatever is stated here, that you connect some load across this A dash, B dash, C dash. Now I am just considering suppose no load is connected across A dash, B dash, C dash, and only the load are connected across a normal delta. Uh, this side star, this side delta, and here you this load is connected drawing high amount of current. So then we have to figure out what is the one resistive load is connected across the secondary delta terminals that draw current I. Mind you, here this I is the line current, therefore we can assume that phase is drawing I by the amount of current. Now, if I have to write down the equation, equivalent balance equation is very important rather the entire solution hinges upon the equivalent balance equation. So I can write this N1 I1 is equal to N2 I2. That gives me I1 is equal to sorry, I1 is equal to N2 by N1 I2. Here, what is my I2? Here, my I2 is I by root 3. So that is my I1. Correct. Now, let us see. This is one load. Let us consider how the second load, which will be connected across the center point, will play a role. Yeah. Now, the center point load is becoming very important and crucial for us. Try to understand that center load. Just let me clean this space. Just let me check whether it's recording or not. Yeah. Since it is recording, just okay, recording has started. So it is recording and screen is also shared. Well, now the second thing is that here we have to figure out that what should be my like what should be or how this determine how much voltage is appearing across. See, here in this problem, no, nothing is mentioned, but it may happen that the per phase impedance of the induction motor is given, and you have been asked to find out the current drawn by the induction motor. So let me show you how things work here. And in this case, the dot becomes very important. Please try to note in the primary side, your dots are connected to form the neutral. So how you will fit the primary side? This capital A, capital B, and capital C will be connected with the three-phase supply line, and they will draw current. They will draw current, and primary side will consume current, and this current will be drawn from the source. Now you think you are having a secondary circuit, but secondary circuit, one thing you have to understand that how much voltage, if you connect A dash, there is certain ratio is mentioned here that A by A dash and A dash by B is equal to say 1 by 2. Or it could be anything. But we have to determine if I know how much voltage is appearing across here. Suppose this side we have 300 volt appearing across this. I have to find out how much voltage would be appearing across C and what voltage will be applied to the induction motor terminal through the P dash point. For your ease of understanding, let me draw the induction motor also. Okay. So this is my induction motor, and with this, I'm going to apply some voltage. Now, let me give you some analogy, DC kind of analogy. Although it is not a one-to-one analogy, so please don't get confused. It is kind of an analogy where at a time instant, say t is equal to t0, you can this analogy is one-to-one valid, but of course this side you are having a time varying supply, so you cannot think about DC, but let us think that DC for our ease of understanding. Let me take only one phase case, and let me show you how this is valid. Because whatever will happen here, the same thing will happen for the other two phrases. Here, these taps are actually working like a potential divider. So, this is my AC, and I have to place my, say, it is one phase equivalent. I have to place my C dash, and the load will be connected between these CA or AC dash, that we don't know how to determine. The answer lies in the dot. See, here the dots are connected to form the division. So you can think that voltage is appearing, or the voltage stress across these is like this. Voltage, like the light terminal is connected with this A, B, and C. Therefore, these light terminals have a role to play how voltage is appearing. At a time instance, let's say T is equal to T naught, we are having this terminal positive, this terminal negative. So accordingly, if you have polarity, how things will happen for this ACR, you have this plus this minus, because this and this, they are parallel to each other. So what you can think about, if you have to connect a load, the normal idea or how we should think about is to connect the load between C dash and C. You never connect a load between A and C dash. You connect a load between C dash and C. That is how you apply voltage across the load. So in that logic, what is the effective number of turns you have here? The effective number of turns you have, the effective number of turns that you have here is this. So basically, this gives you what? This, if you see, this is basically the numerator part becomes 1 by 3 N2, and denominator part is N2. So this side you have the A to C, you have this gives you N2, this gives you 1 by 3 N2. Correct. So, that being said, what you have? You have your voltage C dash. Some voltage is appearing here. So we can draw the circuit diagram like this. Now, one interesting thing, although it looks apparently kind of discrete, A, A dash, B, B dash, and C, C dash. What you have? Here dot, here dot, and here dot. And how the induction motor is connected? This is my induction motor. So what I can do, this diagram, I can do a simplified equivalence, that is like this. And here you have your induction motor. So basically it is a star connection kind of thing. And you have your current drawn by this is I by 2. What is the effective number of turns you have here? You have N2 by 3. So the impact corresponding of this in your primary side will be N1 I1 is equal to N2 by 3 I2 by 3, sorry, I by 2, because the current is I by 2. But don't forget to consider the phase also, because it is mentioned the current is 0.8 power factor. So if we see the total things become N2 by N1, how much is this? This is 2 already stated. So I1 is equal to 2I by root 3 is a phasor plus what you have for the other part. For the other part you have this, right? So you have, sorry, this, just ignore this is something else. You have I1 is equal to, or we can write I1 I. That part I could write I1 R. This I1 due to resistive load and I1 IM is the load due to my this. So this becomes what? This becomes 1 by 3 I. Now what is the angle? Angle is minus 36.86. So this is my I1A. So now what we need to do, we need to find out that I1 will be what? Correct. So that you have to figure out what is going to happen. You have one current that is how much I1 up, count it out 2I by root 3. So 2 by root 3I plus I by 3 angle minus 36.86. So that you just need to figure out that will give you the primary current. So that's done. Now let me click this space. Therefore, you have here, please note that these informations are of no use in this problem. Like these are redundant information. What is needed? You have to find it out for a general transform. General spot character transform. So let us quickly draw the circuit diagram. These two windings should be having equal number of turns. Here it is 86.6%. This is controllable 100%. This center cap. We have the O, here D, E, and this side A. and here we have our teaser winding, and we have our main winding. So teaser winding, here some current is flowing, IT. Here some current is flowing, IM. So this teaser, from this teaser, what you will get? From this teaser, you will get that IA will become IT dash, where IT dash is the reflected current of the teaser winding. So for this, analyzing this one, the easiest method is to go by phasor diagram. So what it says, you have VT, you have VM, let these be IT, let these be IM. Clearly one is leading, another one is lagging. This is lagging, this is leading. And now for that, how your this side phasor will look like. See, VT and VA, they are in phase, and therefore that IP and IA will also be in phase. Thereafter, what you have this side PVC, this side PCB. Once you get PVC, you can draw that IM dash, which is the reflected component of. Now, what is your with this? Let us focus here once again that if this side current is IT dash and this side it is IM, and here we are claiming IV is entering and this side we are claiming IC is entering, then we can write IV is equal to IM minus IT dash by 2, sorry, IM dash, and IC is equal to IM dash minus IM dash minus IT dash by 2. So here we have our IM dash. Fine, fair enough. Now, what we need to do? We have to draw minus IT dash by 2. So let us draw minus IT dash by 2. So that is our minus IT dash by 2. Okay. Now this will give me what? This will give me my IB. What has been asked? The IB phasor must be collinear with your VB. So this is VB and IB must be collinear. So how to figure it out? Very easy. You know theta t. You know this angle. This is your theta m. Theta t and theta m will remain same in the primary side. Then what is your this IA and IT dash by 2, they are parallel. So what you can figure out, this angle, the angle between these two. Okay, now you may ask how much is the angle between these two. Clearly this is 90 minus theta t minus theta m. So from that you can figure out how much is the angle here. That is 90 minus theta t minus theta m. Also, you can figure out the exterior angle of this triangle. And what you need to figure out, you need to figure out just the relation between IT dash by, or better, IT by IM with theta t by theta m. You have to also consider that IT and IM will not be proportionally reflected here, because when IP dash comes here, it gets multiplied by factor 1.15. That is due to that 1 by 0.866. That is the standard formula how you convert spot connection trigger secondary current to primary side current. So that you have to keep in your mind while figuring out. In addition to that, you have to consider N2 by N1 things for trigger, and for main it is just N2 by N1. All right. So these things you should keep in mind, and then you have to figure out basically IP dash, this IP and I, that part you have to figure out, and then from that you have to figure out the ratio of theta t and theta m. Hope that makes sense. Now let us come to the next problem. The next problem, which states find out the current in IA1 when the primary side will be connected in delta, but the secondary switch is unconnected. So basically it is asking us to find out the no load current and ammeter IA2 removed and connect the ammeter in series with one phase wire. So let me draw the circuit diagram here. So the modified circuit will look like this. Since the secondary is not connected, I am not drawing it here. This is your modified circuit diagram. Now, what we need to find out? We need to find out IA1 delta with IA1 is relation between IA1 delta and IA1Y, and also IA2 delta and IA2Y. So first thing first, here you are considering what? You are considering IA2. Please note that if there is no like third harmonic current, then IA2 will reach 0. IA2 will only give you finite current when there is some third harmonic current. So here, what is your IA2? IA2 will become 3 times of I phase third harmonic currents. So if this is I phase 3, this is I phase 3, we know all these third harmonic always remain in the same phase. So they together will give you 3 times of I phase 3. So IA2 will be I phase 3 will be of third harmonic will become. Now it becomes interesting when you connect it in delta, you can assume the same amount of current is flowing through the individual phase. Therefore, what you can expect that IA2 delta is equal to 1 by 3 IA2Y. Then how we can relate IA1 delta with IA1Y? When you will connect this, the line current will become free from third harmonics. Therefore, you should get this. Now, individual line will carry only the fundamental current. So, for one current, even if there is third order harmonics, but not the third harmonics current. Therefore, you can always write IA1 delta equal to IA1 y square minus IA2 delta square, right? Then what do you have? Consider the trans ratio, primary and secondary connected to star as per the diagram, and the load is drawing IP amount of current. So again, we have to connect this whole thing in this manner only, and then we have to figure out how much is IA1. Why? So let this be. Okay, let us go there. So let us write this is IA1 Y L. Here L denotes load. IA2 Y L denotes load. IA3 Y L. So in this case, what will happen? Will be how much? Trans ratio is 1:1. So it will be so that will give you the correct answer. Sorry, my bad. This must be divided by 9 because I2 Y by L, it is actually reading, taking the reading of all three phase harmonic current. Thereby, individual phase will draw how much? This amount of current will be flowing in the individual. This is your expression. Right? Now, this is very simple problem. This could be solved very easily. We just need to KVA balance. What is this? Root 3 V. Say V is the voltage across this. Here phase voltage is equal to your line voltage, and let this be I amount of line current. So root 3 V I, the line current. Now here what we can write here, that this side is root 3 VI. Clearly, this is a kind of first of all, try to understand, although this is an unbalanced load, but interestingly, both these are sharing the same amount of current. So, if this is sorry, the I2, this side is also carrying I2. That means this actually getting circulated through this path. So the secondary side we can write. The secondary side is I2. Secondary side KVA is I2. That is the current. And what is the voltage? Voltage here between these two is root 3V. So we can write root 3V is equal to I2. So that gives me I is equal to I2. Therefore, I is equal to I2, and how much is this current? These currents are, sorry, this, yeah, this, just a minute. I is equal to root 3V. Okay, one thing we can do instead of doing this, we can also think in this manner. Let this be V into I by 2, and the other side is also VI by 2, right? So these are the two KVAs, and what is the these are KVA actually, these are the phasor of the KVA, and that is equal to, this side is pretty simple, root 3V I by 2. So from this equation, you can also find out the value of I in the, or this 2 will carry I by 2, I by 2, and what about this? To think. Clearly, it is not going to be just I, it has to be something better than I, because this currents are not going to be an algebraic sum, rather it is a phasor sum. I'm leaving this as a small exercise for you to find out how much will be your I. Whether I is just I or this will be something else. This let this be something else. Say IA, IB, and IC. Clearly, IB and IC are okay. Magnitude wise, at least we can say I by 2, I by 2. But what about IA? That is a big question. Think about it. The correct answer, I'm just giving you a small hint, will be greater than 1. Now this problem, this is one of the interesting problem. If V2 is not equal to 0, then comment on the impact of V2. So when V2 will show non-zero reading, only when you have oscillating neutral due to the presence of third harmonic voltage. So when you have oscillating neutral, this voltage V2 will be there. So V2, comment on the impact of the V2 present in the reading of V1. However, V1 is measuring the line voltage. And we know in case of star, this V1 is invariant of V2. V1 is invariant of V2. Now, how readings of V2 and V3 are related to each other? See, V2, you have the full winding, right? For V2, what you have? You have the full winding. Say 100 number of turns you have. But for this V3, you have 50 turns. So your V3 will be V2 by 2, because only half of the winding is responsible for neutral voltage in secondary side. How V1 and V4 are related to each other? Okay, V4 is not shown here. This got cropped out. So V4 is like this. So here primary side voltage, it is line voltage, and secondary side, here the phase voltages are becoming 1 by say 1 by, this will become root 3 by 2 of the primary side voltage. So these root 3 by 2 things will create some difference. If you have two identical star, you get V1 is equal to V4, but actually here we get V1 is equal to 3 by 2. Sorry, V4 is equal to root 3 by 2 V1 because of this zigzag winding. Then what you have to find out? Consider the turns ratio on how V3 and V4 are related. V3 and V4 are no way related to each other, because V4 is the line voltage and V3 is the neutral voltage. Just like a star, here you don't have any impact of that. How V5 and V4 are related? V5 and V4, this is an interesting relation. V5 is also free of third harmonic, therefore we will have here V4 just like star connection. V5 is the phase voltage, V4 is the neutral line voltage of the secondary side. If you replace V5 by a DSO, what type of waveform will appear? The beauty of zigzag is that due to this, like we call it interstar kind of thing, this like the half windings voltage, third voltage cancel out each other. Therefore, V5 will also become sinusoidal. So DSO will read a sinusoidal waveform. And utilization factor, you are mature enough to calculate that. You just do it. I have told you all other information, so do it like this. Consider the circuit winding and find out what changes you would observe if you introduce a delta connected tertiary. So, only change the delta connected tertiary you will introduce here. The reading of the voltmeter V2 and V3. The delta connected tertiary will allow flow of a third harmonic current to this winding. So these lines will start drawing third harmonic current, and thereby the both V2, when you have this will imply both your V2 as well as your V3 will become zero. Because due to flow of third harmonic current, your third harmonic voltage component will be eliminated. So that's it. I hope you this will help you in solving the problem.